Hello friends, welcome back to your channel once again. So we are continuing the series of discussing the JEE Advanced paper 2025. So here I've taken one more question. It's a very nice question taken from scattering. Now let us see that in what different ways we can tackle these questions and what we can learn from the question. That's our primary objective, not only the solution, but also different kind of concept and its analysis that we can do from the question is the ultimate priority for us. So method 1, as you can check over here, before going to method 1, let us quickly read through the question once. So there is a mass of mass 2m, as you can check over here. It is going to hit another mass m over here, and then after the collision, as you can check that this mass 2m is going to be scattered at an angle theta with respect to the ground frame, and mass m is going to move in this direction. Let's say this angle is some angle, I can take alpha or phi, whatever, it's up to my choice. So now this question we have to be very careful because of the options. If this mass is m1, if this mass is m2, and in the question if it is being provided that m2 is much greater than 1, then the scattering will lead to the answer pi, because in that case the mass will straight come back after the collision. So that is only in the condition of m2 much greater than m1, and this we can get in Rutherford alpha scattering. So that means the point is that here the angle of deflection theta of this particular mass m1 will depend on impact parameter. This is the most important thing. I will shortly come up with a video where we will be calculating the impact parameter in such kind of cases. But here you have to remember this, that we will be very much tempted to take the option pi, but it is not. It is only achieved under the condition where m2 is much greater than m1. But here the condition is different. Here it is being said that this mass m1 is just double of mass m2. So there is nothing such idea or nothing such kind of concept that we can adapt over here to get the answer. So here to solve these questions, what we are going to do, we are going to take the entire collision into COM reference frame, center of mass reference frame. So we want to see what happens whenever we take the scattering or collision in case of center of mass reference frame. And method 1 is based on that, for which I will make you a little bit work hard more, because in the I button you can see one video out there. If you click the video on the I button, you will get a complete analysis of this particular thing, that is viewing the collision from the center of mass reference frame. So there, if you watch the video, you will see this is the velocity of center of mass, which is given to be 2u/3. This is the velocity of 2m about the center of mass, which is becoming u/3. So, and this is going to be the resultant. So this is going to be the velocity of 2m with respect to ground, this vector, and this is the angle theta over here, that is the angle of scattering. And if you watch the video completely, what you will observe is this particular value remains constant. So this is a constant vector. If this is a constant vector, the orientation of the vector will decide what is going to be the angle of scattering, because if we take this vector in this orientation, then this is going to be the resultant. If this is the resultant, then this angle is going to be theta. So if you see that on a whole, this particular vector can rotate over the periphery of a semicircle. It can rotate like this. It can rotate like this over the periphery of a semicircle. Now for that, if the vector is aligned in this direction, this vector I am talking about, if this is aligned in this direction, then this is going to be the resultant. This angle, radius and tangent, is going to be 90 degree, and this is the maximum value of theta, that is going to be theta max. So here this value is how much? This value is equal to u/3. If this value is u/3, this value is how much? That is equal to 2u/3. So if I substitute the result over here, sine theta max comes how much? It comes u/3 divided by 2u/3. So this becomes half. So there theta max value becomes pi/6. So this is the answer. But for that, I'm requesting you once again, please go through the video and check the detailed analysis of how things happens. You will see some amazing stuff out there. Now let us analyze this. with method 2. Method 2 we have adapted with respect to center of mass reference frame once again, and we are going to see the situation what's happening out there. First we have calculated the velocity of center of mass. As you can check, it is coming how much? 2u by 3. So what is the momentum of 2m with respect to center of mass? 2m into velocity of 2m with respect to center of mass. 2m was having an initial velocity u, center of mass is 2u by 3, so it becomes 2mu by 3. I am calling this momentum as p naught. What is the momentum of p with respect to center of mass? I will do once again, m into velocity of m with respect to center of mass. Same calculation, it becomes minus of p naught. It is supposed to happen because with respect to center of mass before collision, so momentum of the system with respect to center of mass before collision was coming to be how much? 0. So as you can check, with respect to center of mass, 2m is moving rightward with how much momentum? 2mu by 3, and m is moving leftward with how much momentum? That is 2mu by 3. But what happens after collision? Since they have said it's a perfectly elastic collision, so their E is equal to 1. So if E is equal to 1, we know that there is no loss in kinetic energy. If there is no loss in kinetic energy, this value of P is going to remain same, which is equal to the value before collision, that is P naught. Right? So that means this 2m mass will move in this direction, m mass will move in this direction. Correct? With respect to center of mass, they will move anti-parallel to each other. If you watch that video, you will get further more clarity. So I'll write with respect to center of mass, the two masses will move anti-parallel to each other. What's the logic? The logic remains same. That is the momentum of the system with respect to center of mass has to remain how much? 0. So now the same logic I am going to apply. So if this value is going to remain same, this is the vector that I have already explained. It will be around the periphery of a semicircle where the vector magnitude is constant. Maximum angle of scattering will only occur when this is here and this resultant is just perpendicular to the radius vector. So this angle is 90, theta max, it is coming again 30 degree. The answer is equal to pi by 6. So these two approaches that we have seen just now are the conceptual approaches. If you are very thorough with the concept, you can really do these questions very quickly. By the way, I'll suggest you that if you can remember this now onwards, here in this case sin theta max value generally comes to be m2 by m1. I will encourage you to remember this value. If you get similar question like this in JEE main like exam, you can directly put the formula and get the answer. Anyway, right? Okay, so here m2 value is 1, m2 value is this one, and m1 value is this one. So m2 by m1, how much it is coming? m2 is m, m1 is 2m, so sin theta max is equal to half. Directly you can write pi by 6, right? Now method 3, this is the laborious approach. This is the common approach what we have all done in some part of our study. So here I am going to conserve the linear momentum along x-axis as well as along y-axis. Along x-axis before collision 2mu, after collision v 2m into 2m into cos theta. This component is going to be cos theta component, and for this vm it is going to be cos alpha. Y direction, initial momentum is equal to 0. For this particular, how much value we are going to have? This is going to have 2m into v of 2m into sin theta, and in this direction how much you are going to have? M into v of m into sin of alpha. So this is my question number 1, this is my question number 2. Conservation of kinetic energy, since E value is given to be 1, so perfectly elastic collision, half into 2m into u square for this one. After the collision, half into 2m into v2m square plus half into m into vm square. So from there I get an equation, vm square is equal to 2u square minus of 2vm square. Now what I'm going to do, I'm going to simply square and add these two. So if I square and add, what I'm going to get? 4u square plus 4 into v2m square cos square theta minus of 8 into, as you can check the result over here. So here what will happen actually, so this mvm square cos square alpha, mvm square sin square alpha will give you 1, right? So this is getting as vm square. You have to manage the calculation very efficiently, correct? So there 4u square, this one function is there. This one is 4v into 2m square cos square theta. 2ab will lead you minus of this one. This is minus 8 into v2m into cos theta. How I am doing this? To elaborate you I am just taking the function as 2u minus 2 into v2m into cos theta is equal to Vm into cos alpha. I'm squaring this function. Now check 4u square. This is 4v into 2m square cos square theta. 2ab, this sin square theta is equal to Vm square. Managing the equation better, I am not going to the calculation. Here I got this final equation. 3 into v2m square minus 4u v2m into cos theta plus u square is equal to 0. This is a quadratic where ax square plus bx plus c is equal to 0. This is real only when b square minus 4ac must be greater or equal to 0. After doing the calculation, cos square theta greater than equal to 12 by 16, cos theta greater equal to root 3 by 2, theta is again coming how much? Pi by 6, because cos theta value is equal to root 3 by 2. Now, method 4 is based on the same kind of calculation, but I will handle the calculation more efficiently. How? Please look at this. Now I have taken the momentum vector. Conservation of linear momentum, that vectorial expression I am taking. So P naught vector is equal to P2m vector plus PM vector, correct? P naught vector minus P2m vector is equal to PM vector from here only. Now I am squaring this. So once I square P naught square minus 2 P naught into 2 PM plus of P2m square is equal to PM square. Now conservation of kinetic energy will give you P naught square by 2m plus equal to P naught square 2m plus of PM square by m. So PM square is coming how much? That is P naught square by 2 minus of P2m square by 2. Substituting, what result we are getting? 3 into P2m square minus 4 into P naught into P into 2m plus of P naught square is equal to 0. Again it is coming in the form of quadratic ax square plus bx plus c. So again I will put what? B square minus 4ac greater or equal to 0. Since those values are same what we got in the earlier situation, so directly I am going to write the equation is going to give you the result theta is equal to pi by 6. I hope you have enjoyed. I hope you have learned new things. I hope this will give you many more prospect to do similar kind of questions with a little bit of modifications. Wish you all the very best. Happy learning. Bye-bye.